Hi guys, this video today is going to be on what's called reduced row echelon form. It is another way of solving systems of matrices that is, I think, just a lot more direct than the other way we've been talking about. So I wanted to introduce it today. First of all, this deals with the concept of augmented matrices. An augmented matrix combines two matrices together. In other words, we used to, as of yesterday, write some of these matrices as two or three actually matrices. We would have like 3x, 4y, and this is kind of out of order. So anyway, we would have one that had our coefficient matrix, and then one that had our XYZ matrix, and then one that had our answer matrix. We're going to rewrite it as an augmented matrix where those are combined together. The first thing we need to do, though, is we need to make sure that they're all in standard form. So, for instance, I can tell that this first one is a little bit out of order. And so I need to rewrite it into standard form. So can you see, do I have to show my work, or can you tell that I would add that 2z to the other side? Maybe I can write it here because I've got a little bit of space. So you're going to add 2z to the right side and add 2z to the left side to put it into standard form. And so now I have 3x plus 4y plus 2z is equal to 7. The next one is pretty much in standard form already, except do you see that there's something missing? We're missing a z term. And so I'm going to rewrite this, but I'm going to put a 0z in there. And the reason for that is when you first learned about zeros, you learned they were a placeholder. This is going to be a placeholder in our matrix, and so I want to include that in there. Now, the bottom equation is just normal. There's no changes. I'm going to go in and rewrite it, but it's not different at all. So I'm going to create now what's called an augmented matrix, and an augmented matrix is going to, like I said, it's going to take the coefficients and the other side and put them together into one matrix. So what I'm going to do is I'm just going to write all my coefficients and then a 7 at the end. And so 3, 4, 2, and I added a little bit of space, and I'll talk about that space in just a second, and then 7 on the end. And I'm going to do the same with the other one. And in my second equation, I have to include that 0, that placeholder, because my matrix needs to have something in each spot. So if it's missing a z, I need to put a 0 in there for the z. And then my last equation, remember that that would be a -1, right? That's a -1 on the z, and then the 2 on the end. And so when we make this augmented matrix, we then, sometimes you'll see this, and sometimes it'll just be like a thin line. Sometimes it'll be a dotted line. I tried to make mine look like a dotted line. Those should not be ones. So don't be confused by that, thinking those are ones. I tried to erase them just now to make them a little bit more dotted. So those are a dotted line or just a thin line. It's okay to make it just a thin line. And whether it's dotted or solid or whatever, what that is showing you is this used to be its own matrix, and this was its own matrix. And what we just did is we combined them and put them into one matrix. That's where the word augmented comes from. That just means that they've been two of them put together. Okay, that's an augmented matrix. Can you try that on example number 2? Some of these are going to need to be changed, so change them into standard form and then write in the matrices. So pause the video here and do that. Okay, so here is your standard form. Your matrix: 9, -8, 3, 11. 1, -1, 2, 6, -1, 4, 0, 16. And again, you could draw in a dotted line or just a solid line there, showing that this is an augmented matrix. Okay, the whole reason I'm doing this is this makes the calculator steps I think even easier and even more direct than that inverse method that we were doing the other day. So if you will find your graphing calculator and go ahead and enter. And what I did on mine is, let's call this top equation matrix A. Let's call the top matrix A, and the bottom matrix B. And that way we can just enter them both and then we'll talk about what to do with them. So take a second with your calculator and enter these. Now, as far as entering them as an augmented matrix, your calculator doesn't even need that middle line there. It's just a normal matrix. So just enter it as a normal matrix. Like this matrix is going to be a 3 by 4 matrix. And this one also is going to be a 3 by 4 matrix. So go ahead and in your calculator, enter those matrices. Okay, so here is my matrix A. I've entered all of my terms. Again, there's nothing different about it, even though it's augmented. The calculator doesn't care that it's augmented. It's just a matrix as far as the calculator is concerned. Next step is to do something with this matrix, and this is where this reduced row echelon form comes in. We just call it RREF. The reduced row echelon form will just solve your equation, your system with a matrix in one step. So here's what we're going to do. Again, these instructions are printed on your sheet. Okay, so from here, we're going to quit out of this, and then we're going to go back into the matrix menu. So go to second quit, and then second matrix. Okay, so when you do that, you get this menu. We're going to use this math command that we haven't used yet. So we go to the math command, we get this menu, it's got a bunch of things on it, and we have to scroll all the way down. So scroll down past the 9. And we go past the 9 down to the B, and it says RREF. That's what we want to choose. We want to choose RREF. It now asks us, what do we want to do the reduced row echelon form with? Well, we want to do matrix A. So we're going to go to second matrix names and choose matrix A. And now just hit enter. Okay, this is our reduced row echelon form of this matrix. Remember, if you want to do it as a fraction, those instructions are on your paper also. For this one, let's go ahead and do it as a fraction. For the next one, we'll leave it as a decimal, but let's go change this to a fraction. So we're going to go to math and then enter, enter. So math, enter, enter, and now we have it with fractions instead of with decimals. Okay, we need to take a second to write this down on our paper. So go back to your paper and write down this matrix on your paper. Okay, now that you've written it down, we need to talk about what this even means. I'm going to scroll up back to the original problem for just a minute. In this original problem, this column, these were all my x's, these were my y's, and these were my z's. And so now I'm going to scroll back down and show you. This is my X column, this is my Y column, this is my Z column, and then these are like the answers. And so what this row actually means, and you don't have to do this every time, but I'm doing it this time because it's the first time you've seen it. This row actually means 1x plus 0y plus 0z is equal to 1/29th. Or in other words, we could just say those drop off and we get x equals 1/29. So that's what this whole matrix means. It says that x is 1/29. We could do the same thing for the next row. Okay, we get 0x plus 1y plus 0z is equal to 26/29. Or in other words, the 0x and the 0z drop off, and we get y equals 26/29. Okay, so for our last one, we have 0x plus 0y plus 1z is equal to 48/29, or in other words, z equals 48/29. Now, it depends on the context of what the problem is. You might leave it like this, but you might give your answer as a coordinate. And so if you're asking for the answer as a coordinate, you would just list it out this as a coordinate. If it was a word problem, you would explain what these all mean. But that's how you do it with the RREF. I just think it's a little bit more direct than the inverse method. They both work, and they're going to give you the same answer. Take a second right now and pause the video here, go into your calculator, and try example 2. I believe you've already put that into matrix B, and so if you've already put it in, just go through these steps and see what your answer matrix is, and see if you can make sense of what that is as an answer. And let's go ahead and leave this one as a decimal instead of changing it to a fraction. Okay, you should have gotten a matrix, an answer matrix, the RREF, that looks like this. And that tells us that x is 477, y is 519, and z is 321. Maybe those are money values, something costs $4.77, whatever. But those would be your answers for example number 2. If you're not getting those answers, then I would go back and check what you have entered, and maybe you put something in the matrix wrong. Okay, before we end this video, we need to do a couple of things. One thing is, if you have questions, make sure you write questions in the margin. For a summary, you can write whatever you need to in the summary. I'll show you what I am going to write in my summary, but you can really write whatever you want. Here is what I wrote in my summary. You can put whatever you need to. I just wrote you can combine two matrices to make an augmented matrix, and then you can use RREF to solve, or you can use the inverse method from yesterday. They both work. All right, that is all we need to talk about for our lesson today, and then this will be our last lesson before we start reviewing for our test.